Good stuff.
Wonderful. Well, thank you everyone for coming and welcome to the first event in the Enhance's Global Lecture Series on nature-based solutions for tropical coastal protection. So to begin with, I want to just give a brief introduction to our project and what we're doing. So Enhance's is an international multidisciplinary team dedicated to understanding the role of mangroves in protecting the coasts of Suriname and Guyana. And we're collecting new data on the ground, in the water, and from above using drones and satellite imagery to assess how mangroves function within these coastal systems, both in safeguarding shorelines and providing vital ecosystem services. Building on this knowledge, we are developing an innovative engagement platform to share our findings with stakeholders and with the wider public. Now, this lecture series in particular is about bringing experts from diverse disciplines focused on tropical coastal protection together. And through these events, we hope to share knowledge about the role of mangroves in tropical coastal protection, foster meaningful discussion about this, and then also start to build networks that can translate these insights into real practical solutions to real world challenges. So thank you all for attending. I will introduce our keynote speaker for today. This is David Pryor. David Pryor is an experienced waterfront engineer who has been practicing for over 40 years. He has extensive experience in the planning and engineering of marine facilities, including shipyards, ports, and military bases. As a waterfront engineer, Mr. Pryor has delivered projects for the US Navy, US Coast Guard, numerous port authorities, and shipyards. He has developed major projects in the United States, Brazil, Scotland, and the Caribbean. As a resident of Virginia Beach, Virginia, Mr. Pryor has been deeply involved with the impacts of climate change, sea level rise, and coastal flooding. These projects have ranged from assessing potential flood impacts during hurricanes and nor'easters to the engineering of coastal structures to mitigate damage or inundation. Mr. Pryor holds a Bachelor of Science degree in Civil Engineering from Worcester Polytechnic Institute and a Master of Science degree in Engineering Management from Old Dominion University. He has also been certified as a coastal engineer by Old Dominion University and is an ASCE Fellow. He serves on several ASCE committees as well as a PIANC Working Group 213 design guidelines for marine multipurpose ports. And with that, I'm going to go ahead and pass this over to Dave. He's going to be talking about coastal resilience for industrial environments. Thank you, Dave.
Thank you, Zane. First off, thank you all for having me here. I appreciate the invitation. When Zane first asked me to speak on this, I was a little hard pressed on how to present this because, as he's described, most of my work has been in industrial environments, shipyards, ports, military facilities, manufacturing plants. Zane, do you want me to share my presentation?
Yes, please do.
Okay. On one moment here.
Looks great. Wait,
I'm trying to get to the right one. There we go.
Great.
And when he asked me to discuss nature-based solutions, that's not an area we typically turn to in industrial environments. Just to reiterate, as Zane said, I'm a professional engineer. Structural and coastal engineering is my specialty, but over 40 years, I've touched pretty much every system that you could expect to touch in a industrial facility. I've worked throughout the world, had the opportunity to live in some of these countries while we developed these projects. So in addition to developing the project, I got to experience that culture, which is a lot more meaningful than just working remotely. the majority of my work, ports, shipyards, manufacturing, military, and I am active member of several professional societies related to waterfront projects. Now, when I talk about industrial environments, we're talking, as we said, shipyards, ports, manufacturing, military. And what's important with this distinction is that there are certain advantages these facilities have over, say, a municipality, a city, a state, when they're dealing with coastal resilience. We'll get into that in a bit. The impact of these phenomena on these facilities is, you have to remember that a shipyard, their purpose is to fix or repair ships. A port is to move cargo. Military is to be prepared for military missions. Unlike a city, which is trying to protect its population and to protect its infrastructure. So there is a slightly different mindset with these facilities. Their biggest concern, well, there's two biggest concerns. One, of course, survive the event, and number two, get back to normal operations as quickly as possible. So with that, they're looking at the threat to assets, to personnel, products, machinery, vehicles, buildings, sometimes material within those buildings. There's also the interruption of utilities and the interruption of supply chain. So all these are the considerations that go into an industrial environment as opposed to, a broader city. The other thing I should point out is with a lot of these facilities, they're dealing with a much smaller footprint than, say, a city. So it's a little bit more manageable in those cases. So what an industrial environment is generally looking for is something that's easily deployed and recovered, fits their business plan. In other words, it's not going to be an extraordinary expense that ruins their profit for that given year, minimizes the impact to normal operations. Now, some of the assets that I mentioned, a lot of them, they have manpower at their disposal, heavy vehicles, material handling equipment, storage space, but most importantly is autonomy. They can decide if at a certain point in a weather event that they're going to shut down a portion of their shipyard or their base. They can direct personnel to stay away from an area. They can move assets as necessary, whereas, a town or a city cannot simply close a neighborhood because it's become dangerous. People live in that neighborhood. They need to get in there to get their family out. You can't simply shut an area down, whereas these facilities do have that space, decision-making capability. The common solutions, of course, are retreat, elevation, hard defense. Of course, today we're talking about natural defense. And one of the things I always advocate in industrial facilities is operational policy changes. Those are often the most cost-effective. Now, what I want to look at with each one of those is how likely is it to be a solution in an industrial environment. Retreat, well, a shipyard pretty much needs to be on the water. So retreat is not truly an option for them. Likewise, an elevation change has limited opportunities. You pretty much need to have your pier at or near water level. Your warehouses cannot be elevated but so high above that pier, so on and so forth. Hard defenses certainly have potential within these environments. Nature-based defenses, this is where Zane challenged me and made me think, is there are opportunities, but they're limited. You got to find your opportunities there, and we'll touch on some of those later on. Most importantly, as I said, operational policy changes. Case in point, I was working with Georgia Ports some time ago, and they have a large facility where they import autos that's also subject to flooding. And I asked them, well, what do you do when you see a storm event and that area is going to flood? Their answer was, we move the cars. It's that simple. They just find another facility to load them out. Same thing with the shipyard. They can just move everything out of the way, or they can decide we are shutting that area down for 3 days while this storm passes. So let's look at some of the common flood defenses that we often use in industrial environments. There's three types of classifications that I use: temporary, demountable, and fixed. Temporary means you put it down during an event, you pull it back when the event is gone, and return to normal. Demountable means it's somewhat permanent. There might be some human interaction to deploy it. And fixed is something like a flood wall, etc., that is in place permanently, and you just have to work around it. So let's look at what these look like. Temporary flood barriers, as you can see here, this is a large bladder. These are water filled. The advantages are quick and easy to install. They don't require a lot of storage space. You can use a small team to deploy it. As I said, many shipyards, ports, military facilities, they have the personnel they can devote to this when they see a storm coming. It can also, small tears can be repaired while it's in service, and of course it's reusable. On the other hand, you do need, you're restricted in the height and width that you've got. It can be damaged. Their tears can lead to failure of the entire system. It does require a very flat surface, so that might require some preparation of grade beforehand. Other problems, such as if you don't dispel all the water, it can deteriorate it. UV radiation can wear it down. Water freezing the tubes can lead to failure. So there's upsides and downsides to barriers like this. Oops, sorry, I went a little too fast there. Demountable barriers, as I said, they're somewhat permanent. Sometimes you need to go out and do a little human interaction, but you can see there's two types here. This one lays down, and when you see a flood event coming, you go out. There's usually attachment points for these. So you'll have to have a crew go out, attach this facility. As the flood rises, it picks it up and holds water back. You can see on the left side of this photo down below that it's fairly dry, whereas on this side, we've got a foot or two of flooding. The same on the photo above. This is a more rigid system. It takes a little bit of time to deploy it. They are very effective. They're great where you need to have, an intersection, a roadway, or what have you. And last but not least, I want to cover fixed flood defenses. As I said, that's a seawall or something like that. It's permanent, it's reliable, very low maintenance, but it does require a continuous defense system. Disadvantages, they're probably the most expensive option. As I said, it probably needs some sort of contiguous system, which means a mechanical gate or something to that effect. It is an impact to the environment. Quite frankly, they're not very attractive. So now, of course, in an industrial environment, attractive is not the highest requirement. Now, with that being said, usually it's a combination of these defenses that we can rely on. Of course, this purpose is to talk about fixed defenses, and here I'm talking to the choir here. The advantages are they're inexpensive, they're low maintenance, and it obviously reduces the environmental impact. The disadvantages is it does take up a footprint, and it takes time to mature, and in many cases, it's just a partial solution. On the other hand, all the other traditional defenses I presented are partial solutions. There's no singular way to solve these problems. Usually requires a combination of these. So let's look at incorporating this into industrial environments. As I said, this is, to me, a challenge because you've got to have all the right elements come together to deploy a nature-based solution. So the first thing that comes to mind is shoreline protection. That's where we have more of a natural shoreline, and what we want to do is prevent erosion, prevent flooding, etc. Typical methods of doing that: living shorelines, breakwaters, and riprap. The problem with industrial environments is you very rarely have a natural shoreline that you're protecting. But there are opportunities. As I said, most industrial environments, you need deep water access and you've got navigation channels to contend with, either close to your facility or at least an approach channel coming in. That limits where you can put nature-based solutions. Of course, I'm sure most of you are familiar with living shorelines. The concept here is that on the outer area, you have a breakwater of some sort. It could be a core log, it could be rubble. This is to take the wave energy down. Once you get inside of the core log, we transition up into this area where we vegetate it with subaqueous vegetation, some that's partially submerged in a tidal marsh, and on up to your upland. And the idea is that as sea levels rise, that this vegetation can migrate up to shore and provide constant protection to the shoreline. This really relies on a shallow water environment, which, as I said, it's rare to find that in uh, industrial environments, but I can give you an example of where we could use an application like this. I just brought up this one photo just to show you what a living shoreline looks like once it's in operation. And you can see, very flat, very wide, very shallow. There is a facility near where I live right now. It's Norfolk International Terminal. As you can see, we have the Atlantic Ocean on the east. It transitions into the Chesapeake Bay, the James River, and NIT is this facility right here. This is a close-up, and you can see that all the operations are out here on the west side of the facility. But if we look on the back side here, we have a vegetated shoreline. It is susceptible to some wave action, so the Port Authority's concerned about erosion of this bank. So here, we do have an opportunity to implement a living shoreline or some sort of nature-based solution. Breakwaters are another example. These are some examples that I've shown. This is a sheet pile breakwater. Here we have a more traditional stone breakwater. Another facility near here, Newport News Shipbuilding. This is on the James River, not far from the facility that I've shown you. In fact, that facility that I showed you a moment ago was right here. Now we're looking at Newport News Shipbuilding, which is this area here. On the James River, it's subject to 14 miles of fetch. As a matter of fact, I was at this location yesterday, fairly windy day, and there were quite a few whitecaps right out here in this area. They do some vessel loading out that requires a very still water, as well as they're not particularly fond of water coming over the bulkhead and impacting their facility. So this gives us an opportunity. You can see here that while there's deep water, this dashed line you see here, this is the federal channel. So clearly we don't want to go out in there, but once we get out of the federal channel, it gets down to 7 feet, 9 feet, 2 feet. So we have the opportunity here to insert a nature-based breakwater of some sort. I know mangroves are one of the things we talk about. Virginia is not exactly conducive to mangroves, but there are other options we could look at. The same concept as the mangrove, but some method to take the wave energy out. It's not particularly deep. We wouldn't be blocking navigable waterways. So there is another opportunity for the establishment of a nature-based solution, as opposed to, building a sheet pile breakwater like I showed in the previous photo. Moving along, the considerations with that is, of course, we don't want to be a hazard to navigation. So anything we build has got to stay clear of the navigational channels, as well as looking at the traffic that does need to access the facility. In a case like that, we might want to look at a sediment transport study to see how that's going to interrupt the flow of sediment down the James River. Is it going to accrete sediment behind that breakwater in front of it? Is it going to start directing sediment towards the navigation channel, which will then require additional dredging? Those are some of the considerations. As I mentioned, of course, a shallow water location, because building a breakwater like that in, say, 20 or 30 feet of water is now going to require 60 to 100 feet of width and quite a bit of buildup. And that would further add the time as we stabilize that whole, that mound, if you will. So those are some of the considerations that would go into an application like that. Deep water maintenance is also an area that possibly we can use nature-based solutions as opposed to hardened structures. This is a shipyard I worked on some 15 years ago down in Brazil. This is in the state of Bahia, and we're on the Paraguaçu River. You can't see it, but right out here is a very large bay. Water is flowing from the left to the right. And this is the facility here. Very low-lying area. As you can see, we have the smaller river coming out here, which obviously brings sediment with it. So that I want to focus on this area down here. You can see they have a loadout quay right there. Well, we want to make sure that we don't have sediment deposits in front of this quay that requires constant dredging. So the stream will come down, it's going to deposit sediment, as you can see, and then it'll start dispersing out in the water column and dropping some of it, not all of it, but some of it right in front of that quay. So to me, this is a good candidate for channel management. Nature-based solutions can redirect that sediment deposit, maintain deep water, and then provide all the environmental benefits of the nature-based solution. So let's take a look at how that would work. If we build that breakwater, what have you, something to channel the water further outward, it's going to just disperse the sediment further out as opposed to right in front of here. It's a fairly wide river, so once it gets further out, I'm sure it's going to get picked up and moved down. With that, again, the considerations, let's not be a hazard to navigation. We have to consider the upriver traffic. In this particular case, there's one facility just a bit to the west, and then it's pretty much jungle after that. So there's not a whole lot of development further up the river that we're interrupting. We'd want to look at a sediment dispersion study to make sure that we are projecting the sediment as we think it's going to go. Coordination with the neighbors is always a nice thing. As I said, there's a facility right next door. Let's make sure we're not interrupting their operations. And with any sort of implementation, you want to coordinate with city, state, federal plans to make sure it fits the bigger picture of what they're trying to accomplish. In this particular location, because they are fairly isolated, I don't think it would be a big impact, but we never want to assume that things are not going to be an impact. Another thing to consider is nature-based solutions to protect the facility, what I call beyond the gate. So often we're looking at coastal flooding, sea level rise, storm surge, as it impacts us from the water in. But a lot of facilities, they're protected at the waterline because they're on bulkheads, they're elevated up 2 to 3 meters above the waterline, which is generally safe. However, their access roads in could be the issue. So what I want to do is let's look at Paraguaçu again. As I said, this is very low lying. Right back here is their access road. You can see we've got a stream here, we've got the river here. I think this is mostly mangrove here. So this is all very low lying in this area. While they're protected more or less from elevation on the riverside, here's where they could be impacted because if this floods, personnel cannot get to work, your supplies chain is interrupted. Now they have issues on the backside. The facility's fine, just nobody can get in or out. So here we have the potential for backside flooding. Again, we can look at some nature-based solutions with a raised berm, vegetation. By placing these in strategic locations, we can protect this facility. Now, as I mentioned much earlier in this presentation, not usually one solution is not the silver bullet for everything. So here we might also want to consider combining it with mechanical structures, maybe a few automated gates that tie into a raised berm that protects the facility overall. Again, this is one example. Here, they do have the wide footprint for something like this. We could also design, instead of these gates, we could have a raised roadway where it just goes over at that location and protects the facility. And of course, we also have to look at the total protection. If we need to extend these further to the northeast. That's what we have to do until we get a relatively safe elevation. Let's look at a few bad applications where nature-based solutions are not an appropriate solution. Another facility I worked at many years ago in Scotland. In fact, I saw that they finally opened this facility. It's a new shipyard in Glasgow, designed to build military vessels for the Royal Navy. This is on the River Clyde. As you can see, it's a very narrow river, only a few 100 meters across. It's a very busy river. There is a considerable amount of industry upriver in this case is to the bottom of the page, towards the top of the pages, out towards the Atlantic. It is a deep water facility. I think it's dredged to about 12 meters right in this area. And to do any sort of nature-based solution in this area would be an incredible impact to how they operate. They would not be able to get their ships in and out safely. They would not be able to have vessels arrive safely. So this is an example where nature-based solutions just aren't going to be much of a help. Another facility, Kelowna Shipyard, I worked there many years ago. As you can see, this is the Elizabeth River, not far, just downriver from where I showed you Norfolk International Terminals earlier. Again, very narrow river. There's considerable upriver traffic in these facilities here. Another congested waterway. It's very close to the federal channel, so deep water. And again, a big impact to their operations. It would be extremely difficult to work in any nature-based solutions, except maybe up here where you see Spottico Creek, that they could do some protection in that area. But as far as the waterfront, they would be hard pressed to do much. So with that, one of the things I try to wrap up, I've done this presentation for many shipyards and other industrial facilities previously, but not with the nature-based solution focus. But what I always try to encourage any of these facilities is, number one, consider operational changes before you go making physical changes. It's simpler, it's less expensive, and often really does solve the problem. With an industrial facility, we want to consider the downtime and recovery time. With that point, nature-based solutions is a good player to address both of those, if combined with other techniques, mechanical gates where necessary, etc. Of course, you have to coordinate any resiliency plan with neighbors, city, state. We want to use available labor and resources. In industrial environments, to construct, say, a berm, a mangrove, usually you don't have the right labor there, but that's not a showstopper. I mean, that's a specialty construction that facility simply doesn't have. Of course, we want to monitor tide and storm surge. That goes back towards operational changes. If you can predict when you're going to have flooding, you know when and how to deploy your resources. And this is 2025. GIS is a very common tool. You can use GIS to predict when to deploy these flood defenses, how to deploy them. And that's another subject for another day, but it's one of the points I try to make to these facilities, to use technology to your advantage to help you with the problem of coastal flooding, coastal resilience. With that, I believe I'm through it all, and I'll take any questions that you might have.